So on a side note, I am recording all my classes today. Whatever questions they ask, it's usually different. And you can check that out in the slide later. I will also post whatever we go over from this document into Schoology as well. So there's really no reason that we all shouldn't get like a 50 out of 50 on this part for the practice test, because I'm also gonna upload it to Schoology, so it's just on you to like look at it, do it, and all that stuff. All right, but number 2, the Frisbee Club has 19 members. The number of games won in a tournament this season are listed below. First, you need to create a box plot, not to be confused with a dot plot. That always happens every year. Okay, it has to be a box plot. So for a box plot, you need what information from the data? Bron? The 5-number summary, which consists of what? Anyone can answer that? Brian? Okay, so median, minimum, maximum, and there's not 4 quartiles, but the other quartiles, which are our Q1 or Q3. All right, so yeah, that's my 5-number summary. Minimum, maximum. So what is my smallest number in the data set? Okay, good. That would be my minimum. What is my biggest number in the data set? And then we have to figure out what our median is. There's ways to do that in Desmos. There's ways to do that by hand. Both, I think, are equally easy. I cannot help you with Desmos tomorrow on the test. All right, that wouldn't happen during state testing, so I have to treat it the same. You either know how to do it with the calculator, or you need to know how to do it by hand. That's why I taught you both ways. This time I'll show you by hand. So if I have 19 data points, you know, you could do the left, right. I know that my middle number is going to be this one, just from looking at it. It has, how many is that? 3, 6, 9 numbers to the left of it, and then 9 numbers to the right of it. So I know that's going to be my median. You have to establish that first before you can identify your Q1 and your Q3. Do you guys remember the definitions for Q1 and Q3? Okay, I heard some I forgot. Do we remember how to find Q1 by hand? Maybe. Yeah, no. Brian?
I got 8 for one.
Okay, so let's see. Here's how. Remember, Q1 is median of your lower half. I will also show you in Desmos, but you need to know both because someone's going to forget how to use those. All right, so this is my lower half, right? Because here's my median. So I'm going to go left, right, until I get a middle number or middle 2 numbers. And this data happens to be in numerical order already. If it wasn't, I'd have to make sure that it was. And make this look more like a all right, and then Q3 is the median of my Q3 is the median of my upper half. So good. Find out what the middle number is. And yes, it will be 17. So now that you have your 5-number summary, and if you use Desmos, it should still tell you that same data that I just acquired. Then you make your box plot. So figure out what to label for your number line. So if it starts at 3 and ends at 40, maybe I'll consider counting by like 5 or 10 because I have a small screen right now. All right, for you guys, I would suggest counting by 5. I just don't have that much room right now. And then I need to have a dot over where the 3 would approximately be, which is here. A dot where the 8 would approximately be, where the 15 would be, the 17, and the 40. Which dots make up my box? I put all the dots where my 5-number summary goes. Which ones make up the box in my box plot? Ron? Good. So these 3 in the middle, I'm gonna put vertical lines through them because they're gonna make up my box. Like this. And then I'm gonna connect it to my minimum and my maximum. That's how you make a box plot. Questions on that? Okay, there's another part to this, so let's see what it is. What measure of center is most appropriate to use to describe a typical value for the data in this distribution and explain your reasoning? So if you get the answer right and you don't explain, you're losing half of those points by not explaining. Even if you don't really know, just say something. All right, but measures of center, you really only have 2 options. What are my options? Mean or median. Based on how this looks, will I use my mean or my median? Median. And why? Perfect, because the data is skewed right. If you want to be like, I don't know, more descriptive, you could say the median is not affected by outliers. Because it's not. The mean for sure is. And since my data is skewed, that means I probably have an outlier. Which is probably what number? 40. All right. So that's a good explanation. Questions on that part? All right. Then it asks what's an appropriate measure for variability. So what are my 2 options for variability? MAD, IQR, and standard deviation. If median's my better measure of center, then what does it have to be for the spread? IQR. So IQR and then Y. Basically the same reason from up here. Because the data is skewed. The IQR is not affected by outliers. Whereas the standard deviation is affected by outliers. All right, IQR is that middle 50% of the data, not the entire data itself. So it's not affected by outliers. Good on that one. All right, we'll come back to number 3 later. I want to give other people a chance to have their questions asked. So what other questions do we have on either study guide? The puzzle piece or this one? Yes. Okay, so then we'll just do number 3 then. All right. All right, so number 3 on this one. So we have May arranges students in her art class from shortest to tallest and measures the height in inches of each student in the class. The heights of the 20 shortest students are summarized in the histogram below. So that's already on the histogram, the 20 shortest students is already drawn for you. And then we have the tallest 6 students have their heights right here. We need to complete the histogram using the data for the tallest 6 students. So if I need to complete the histogram that's already partially there, you need to keep the intervals consistent. So what are the intervals for the histogram that's on your paper? Like what numbers belong in this bar? Okay, then let me backtrack for a second. What does my y-axis of my histogram always have to tell me? The frequency. So that tells me how often a data point, which is down on the x-axis would be my data points, occurred in the set of data. So I don't know which of these numbers are 60 exactly, but I know that they're from 60 to what? When does it end? 62. Because if this is 65, then they must be counting by one. So here's 61, 2, 63, 64, we go here. 65, 66, 68. I'm labeling the ones that are the ending numbers, I guess you could say. Because we're gonna need to keep that consistent. So it's intervals of 2. All right, so it's intervals of 2. So where it ends at, so right here is like 72 to 74. Keep in mind that's really like 72.0 to 73.9. Because once it hits that 74, it should be in its own bar. All right, so also keep that in mind when you're making it. And then if it ends at like the 74, then my next interval should go from 74 to 76. 76 to 78, because that's intervals of 2. Make sense? And then you keep going. So 78 to 80. 80 to 82. 82 to 84. And let me see what my highest data point is. Okay, so let's keep going. And then 84 to 86. So I'm basically making a frequency table. All right, here's like the data, if it falls within these ranges. Again, remember if it hits the higher number in that range, it should really be bumped to the next column. And then you need to put your frequency to kind of keep it organized. So do I have any from 74 to 76? That I need to put on my histogram. So then don't put anything for that interval, leave it blank. 76 through 78. No, 78 through 80. How many? Technically just one. Because once it hits that higher number in each interval, because remember they overlap, then it moves to the next one. So from the 78 to 80, I need to have a height of 1. So that would be this number right here. What about from 80 to 82? 2, because that's where the 80s go. So then this one, next one. From 82 to 84. 84 to 86. 2. So that's gonna help me figure out where to put these bars. So nothing from 74 to 76, nothing from 76 to 78. But out of the 78 to the 80, it needs to be a height of 1. From the 80 to the 82 needs to be a height of 2. So it should start at the beginning number and at the last number, right? From 82 to 84 should be a height of 1. And 84 to 86 should be a height of 2. So that's what you should have drawn in on your histogram. It's bars that look like this. It's space in between. Good there? Okay. So when I grade it, I'll be looking for, do they have the right intervals? Did they leave the right spots blank if they're supposed to be blanks? Did they have the right heights? Are the bars touching? Things like that. Any other questions from either portion of the study guide? All right, and then for the rest of this one, by the way, it says use the shape of the distribution to compare the mean and the median. Are they equal? If not, which is greater? So what do you think? Are the mean and median equal based off of this histogram? They're not. How do you know? First of all, you'll never be able to do the math from this because you don't know what the entire data set is. So you'll never be able to actually find the mean or median of this histogram. You tell approximately where it is, but not exactly. But how do you know that they're not equal? What tells you that? Okay, I'm not just gonna tell you, so if someone out there knows and they're just not sharing. How do I know that the mean and median are not equal to each other from the shape of this histogram? When are they equal to each other? So you'll never actually be able to know, like, the exact median or the exact mean of this. The question is, how do you know when the mean and median are equal? Based off of the shape alone, no calculation. All right, I'm not gonna tell you because you guys will just have to study and figure it out, or we can talk about it now and see if you're right. All right, so any other questions from either study guide? Only one. Open slides.
Someone else?
On the puzzle piece?
Yeah.
Okay. So remember, I'm not just gonna do all the work for you, like you guys can look it up yourself, look through your notes and figure out why this is not gonna be equal. And have the reasoning for that. I'm not just blindly doing problems up here for my benefit. All right, anyway, on the multiple choice part. Question 2 was requested. All right, so for which distribution shape is it usually appropriate to use the median when summarizing the data? So bell-shaped literally looks like a bell, something like this. Would we use the mean or median for that? Then don't pick the first one. Symmetric, it could be really anything as long as you can draw a line down the middle and it looks like mirror images on both sides. So in that case, would we use the mean or the median? All right, skewed, so that could be right skewed or left skewed. Would I use the mean or the median? That's when we use the median. All right, uniform just means that like it's all on the same level. So if you have like a dot plot, it might look like this. All right, all across. Would you use the mean or median for that? For uniform, you would use the mean because it is symmetric. So that's how you can tell. If it's symmetric, you use the mean. If it's not, you use the median just for my outliers. Questions on that one? All right. Any other questions from either study guide? Okay, what is it? I'm not like your monkey doing questions to you.
No, I know that.
Just what is confusing to you that I can help you with?
Bingo.
Okay. All right, so number 5. Look at the dot plot below, and we're completing a frequency table. So what are frequency tables, class? What does frequency mean when we're talking about data? It would be a y-axis if it was a histogram, yes? How often, when is it? How often that data point appears in the set? Good. So like, for example, this one's partially filled out. 5 appears 3 times. That's why I have a frequency of 3. What appears 2 times? 6. 10 does also, but 10 is down here, so I wouldn't put 10 right there. Again, the frequency of 10 is 2, so I'll go ahead and fill that one in. And then what has a frequency of 3 that isn't listed already? Then the 7 goes there. And then for the 8, how often does that occur? Okay, I counted that. All right, simple enough. On a test, you can identify the right frequency table from the given data set. All right, any other questions? That you still have trouble with. If you have trouble with it now, you're gonna have trouble with it tomorrow. All right, going once. And twice. All right then, if you have questions to ask me privately, you can,